This Dr. T's Probability Basics video is the continuation of conditional probabilities and the multiplication rule. So picking up where we left off, we're talking about the multiplication rule, and we imagine we've done a survey of 52 12th graders. 4 of those had a 4.0 GPA. This person we're calling student A. 4 of those had 0.25, and these folks we're calling student B. We are trying to find the probability that we just randomly choose 2 surveys out of our pile, and one of those surveys will be of a student who had a 4.0 GPA, and the other survey will be of one of the students who had a 0.25 GPA. Now, this is our entire population of surveys is 52. So once we pull the first one out, we can't replace it with a different survey. That makes this a dependent relationship, because the number we have left to choose from when we pull our second survey has decreased by 1. It's dependent on whatever happened before. Okay. So we have the probability of pulling student A and student B. Because this is a dependent probability, the formula is probability of student A times probability of student B given student A. So the first survey that we pull, we know that there are 4 students who had a 4.0 GPA, and we know that there were 4 that had a 0.25 GPA. So we know that the numerators in our probabilities are 4, because there's 4 opportunities for us to grab one of the surveys that has a GPA of either 4.0 or 0.25. Now, we know our population of surveys was 52. So, for the first survey that we pull, the denominator is going to be 52. But as soon as we have pulled that initial survey, our denominator goes down by 1. So the denominator will be 51. Let's fix this here. This is not additive. This is multiplicative. Okay. What we come out with here, if you were to plug this into your calculator, we'll get 16. It's 4 times 4. And I'll wait for you to plug in the 52 times 51 for the denominator. I came up with 2652, which leaves us with a conditional probability that we will pull 2 surveys out of our pile, and one of the surveys will be for a student whose GPA was 4.0, and the other will be for a student whose GPA was 0.25. I'd like to go ahead and work through a couple more probability examples for everyone. Hopefully by the end of this video, you'll feel a little more comfortable. Let's say we're given this problem. The probability that a person who is driving while intoxicated is stopped by police is 0.85. What is the probability that 3 other intoxicated drivers are also stopped by police? As criminology and criminal justice students, you know that it's a success when a police officer is able to take an intoxicated driver off the street. So the probability that each driver is caught, that's the success, right? That each driver is caught. is 0.85. So the probability that we're going to work is the probability that 3 drivers who are driving under the influence or driving while intoxicated are caught by police. And we know that catching each driver, 0.85 probability, and there's 3. So all we have to do is multiply the probability 3 times, and we'll see that roughly the probability that all 3 are caught is about 0.614. Now with this type of problem, I could also figure out what is the probability that none of the 3 drivers get caught. I want you to think back to the beginning of the probability basics, conditional probabilities, and multiplication rule video, the first one, where I discuss what empirical probability is, right? From that range between 0 and 1. So we know the probability that an intoxicated driver is stopped by police, in this example, is 0.85. Well, if knowing for sure that someone will get stopped while driving intoxicated is 1, then we can subtract the probability that we have. And this is going to give us the probability of 1 driver not getting caught, or in other words, a failure, right? And that's 0.15. So if we're trying to figure out the probability that someone driving under the influence or driving while intoxicated is not caught, and what we want to know is maybe all 3 DUI drivers are not caught, it's the same kind of idea as what we did before. We can just multiply this failure probability, 0.15, 3 times. And we can see that the probability that none of the 3 other intoxicated drivers are stopped by police while they're driving recklessly, a failure, is quite small in this example, 0.003.